We're going to use the complementary angle theorem to simplify some expressions. You can see these two expressions I have up on the board. Notice that in each of these two expressions, the angles are different. However, the angles are complements of each other. That is, they add up to 90 degrees. So one thing I want to do is change all the angles to be the same. So in this first problem, I want to change so that everything is either 10 degrees or everything is 80 degrees. It doesn't matter. But both of the trig functions need to have the same angle in it. So I'm going to change them all to 10 degrees. Okay, so the first one is already 10 degrees. So let me leave that the same. However, the bottom is 80. So I'm going to change it to the complement, which is 10. But if I change the angle to the complement, then I must also change the function to the cofunction. What's the cofunction of tangent? That would be cotangent. So since I've changed the angle, I must also change the function to its cofunction. And now we have something that we actually can simplify. What's cotangent of 10 degrees over cotangent of 10 degrees? Well, since they're the same, they cancel each other out, and we get 1. Okay, what about this second problem? Well, these two angles add up to 90 degrees, so they're complements of each other. So let me change them all to either 1 degree or all to 89 degrees. Let's do 1 degree because it's shorter to write. Sine of 1 degree minus, now I'm going to change this to 1 degree, but if I change the angle to its complement, then I have to change the function to its cofunction. What's the cofunction of cosine? And that's sine. So again, I've changed the angle, but if I change the angle, I also must change the function to its cofunction. And now I have something that I can simplify. Sine of 1 degree minus sine of 1 degree is 0. Okay, let's try another one. So again, there's different angles. I want to change to the same angle. Are they complements of each other? Is 75 plus 15 90? Yes, it is. So they are complements of each other. So let's change everything to 75 or to 15. Again, it doesn't matter. I'll go with 15. So I'm going to keep this one as cosecant of 15 because it already has the 15. This second one, cosine, I'm going to change the angle to the complement. So I have to change the function to its cofunction. The cofunction of cosine is sine. Okay. So now I have cosecant of 15 times sine of 15. They're both the same angles. So now I have an extra step. I'm going to have to use an identity. Also, another thing in trig is when in doubt, you can change everything down to cosines and sines. So I'm going to use an identity, which I'm going to change cosecant to, I know that's something else in terms of sine. It's the reciprocal of sine. So I'm going to write this as 1 over sine, that's an identity that I'm using, times the sine that was there. I put that over 1. Now we can see it can easily simplify. Okay, so like the last problem, these problems we might need to use a combination of the complementary angle theorem and maybe some identities. Okay, let's look at this first problem. We've got 40 degrees and 50 degrees. They add up to 90, so we can use the complementary angle theorem. Let's change them all to 50 degrees. Why not? What is the cofunction of sine? That's cosine. Since I'm changing it to its cofunction, I have to change the angle to its complement. 50 degrees. The other one is 50 degrees, so I'm not going to touch it. And what's cosine squared plus sine squared if the angles are the same? That equals 1. That's an identity you should know by heart. What about this second one? 87 plus 3 is 90. They are complements of each other, so we can change them to their cofunctions. Let's keep everything at 3 degrees. I'll keep this first one the same, but the second one I'm going to change to its cofunction. The cofunction of cotangent is tangent. And the complement of 87, complement of 87 is 3. Okay. Can you see this equals 1 because they're reciprocals of each other? However, if you were in doubt, you could change everything to sines and cosines. Cotangent is cosine over sine, and tangent is sine over cosine. So when in doubt, you could change everything to sines and cosines. And what happens? Cosine, cosine cancel, sine, sine cancel, and this is equal to 1. Okay, here's the last one we have, probably the most difficult. All right, we've got different angles. They all add up. The different angles add up to 90. 20 plus 70 is 90. So I know I can change them all to the same angle. So let's change them all to 20. Okay, so secant stays the same. Secant of 20. Cosecant is now going to change to secant because that's his cofunction of 20 minus tangent of 20. That stays the same. And cotangent of 70, I'm going to change it to its cofunction, which is tangent. Okay, so let me rewrite this. I've got secant times secant, and I'm going to write that as secant squared of 20 degrees minus tangent times tangent, so that's tangent squared of 20 degrees. Okay, so here's where I might need to use an identity. Like I said before, I don't have this identity memorized, but I know there's an identity involving tangent squared and secant squared, so I have to derive it. So let me just derive it over on the side, or maybe up here. And I know it derives from sine squared plus cosine squared equals 1. And if I divide everything by cosine squared, I'll get sine over cosine is tangent squared plus 1 equals the reciprocal of cosine is secant. Okay, so here is an identity that I could use. Like I said in the previous video, Pythagorean's identities, I don't have that one memorized. I kind of derive it every single time. So I see I can use this. I'm going to replace secant, because secant is the same as tangent squared plus 1. So I'm going to replace this with tangent squared, in this case theta is 20 degrees, plus 1. So I'm replacing that because this identity says secant squared is the same as tangent squared plus 1. So I'll replace that, and now I have tangent squared theta plus 1. I'm sorry, this problem is 20 plus 1 minus tangent squared of 20. What happens to the tangent squareds? They cancel, and we get